Assalamu alaikum. This is Sumashimo, Department Electrical and Computer Engineering, Rajshahi University of Engineering and Technology. And it is a great honor and opportunity to present our paper in the International Conference on Automation, Control and Mechatronics for Industry 4. And my research topic is a polarization splitter using dual core photonic crystal fiber. And these are the contents of my presentation. Now we need to know what is photonic crystal fiber. Photonic crystal fiber is a new class of optical fiber based on the properties of photonic crystals. It has ability to confine light in the hollow cores, which is not possible in conventional optical fiber. Photonic crystal fiber is now finding applications in fiber optic communications, fiber lasers, nonlinear devices, high power transmission, highly sensitive gas sensors, and other areas. Now we need to know what is polarization splitter. Polarization Polarization splitter is that which can separate one light beam into two orthogonal polarization states. It can avoid pulse broadening and signal distortion. By using a conventional optical fiber, we get such a splitter which is long length and narrow working bandwidth. Uh, but our focus is to get short length and wide working bandwidth. For this, we use photonic crystal fiber in polarization splitter. And now I will discuss about literature review. In paper 2, they have focused on graphene layer filled dual core photonic crystal fiber and their bandwidth is 610 nanometer and the length is 4.8 millimeter and their limitation is very long length. And in paper 3, they have focused on telluride glass with and gold wire. Their extinction ratio is 174.92 decibel at the wavelength of 1.55 micrometer and the length is 1.079 millimeter. Their extinction ratio is high but long length. And this is the limitation of this splitter. And in paper 4, we have produced a short length splitter, low insertion loss, and the limitation is narrow bandwidth and low extinction ratio. In paper 5, they have focused on dual core photonic crystal fiber with telluride glass. Extinction ratio is 107.21 decibel and the splitter length is 89.05 micrometer and the bandwidth is 150 nanometer and the limitation of this splitter is narrow working bandwidth. And these are the objectives of my presentation. And these are the methodology. For designing a waveguide, we need to use finite element method-based tool, and for investigating the characteristics, we need to use COMSOL multiphysics, and for plotting the data, we need to use Microsoft Excel or MATLAB. But here I have used Microsoft Excel 2015. Here is the proposed model, and here I have used three types of materials are used. Air is used for cladding region. Silica is the background material and gold metal is also used for increasing the coupling length. These are the air hole selection and these are the silica region. And in this figure, these two air holes are used for gold material and in the right side figure, this is the PML portion. In this figure, meshing is shown. There are many types of meshing, but my element size was extra fine because by doing this we will get more mesh and more mesh will make the calculation more accurate. And in this figure, the light confinement in the core region is shown. And these are the modal electric fields. The number 1 is X even, the number 2 is X odd, number 3 is Y odd, and number 4 is Y even polarized light. When the two arrow surface is in the same direction, then it is known as even polarized light, and when the direction of the light is opposite direction, then it is known as odd polarized light. This is the graph of wavelength versus effective refractive index. In this figure, it is shown that how the effective refractive changes with the variation of wavelength. And in this figure, the phase variation is shown from 1.9 to 2.2 micrometer, so that we can get the optimized value. When we increase the pitch value gradually, then the coupling length also increases as the power in the core becomes more anomalous. But if the pitch is more decreased, the adjacent air holes may collide. So we will take the optimized value where the coupling length will 2, and we take the pitch value is 2.1 for getting the CLR is equal to 2. And in this figure, the diameter is varied from 1.1 to 1.24, and we take a 1.2 value for getting CLR is equal to 2. And here, in similar region, diameter of small air holes and diameter of ellipse in x-axis also varied, and we get the optimized values. Here, the y-axis diameter of ellipse is varied to reach CLR is equal to 2, and then in next slide. Here, the effect of gold and without gold graph is shown, and we can notice without gold the CLR cannot reach at the point 2, but if we use gold we can easily reach at the point of 2. And after optimizing all the parameters, we get these values. These are the optimized value, and these are the required equation. Here is the normalized output power, and when the normalized power of a particular polarized ray is maximum in a core, then the other will be minimum in the other core. Normalized power is a function of propagation distance. The length of splitter can be measured from the normalized output curve of a core. And in this figure, at the propagation distance 481.73 micrometer, the normalized power of Y polarized ray is minimum, where the X polarized ray is maximum in core A. And in this figure, it shows the extinction ratio spectra, which is used for determining the working bandwidth. And at the point 1.55 micrometer wavelength, the splitter shows a high extinction ratio of minus 98 decibel, and the working bandwidth is 200 nanometer, which covers S, C, L, and U bands. These are the results. Here is a comparison table between the proposed device and other works. Here we can see some papers have short splitter length but at a time narrow working bandwidth. Similarly, some papers have wide bandwidth but long splitter length. But we try to produce short and wide working bandwidth at the same time. So we can say overall our splitter gives better output based on the previously reported splitter. And these are the limitations. And here are the future work. These are the references. Thank you. Any question?